Light first, please. Thank you. All right, class time. Let's go. Thank you. All right, so on the front side, I have this as a problem. What could be some errors that might take place with this problem?
-5, changing the sign.
Yeah, making sure that sign stays consistent. So this whole thing needs to come here as well as here. Give me that. If you goofed up on that, you goofed up on the problem. Now this one, all the signs stay the same. I've seen students that have distributed all the way to here. Just make sure you don't. And then if you go through, what did you get for an answer?
-7 over 15.
-7 over 15. So if you add the, so I get 30x over here. I already have 4, and that's 14. Get x equals 14 over 30, which reduces to 7 over 15. So watch out on the reducing, because if you don't reduce it, it's a point off. I mean, if you made the error on your homework, don't worry about it. You know, just make the correction. Is that all right, how I have it worked? I didn't really talk you through every single part, but did you get the correct answer? Or at least the non-reduced correct answer? Sweet. All right, problem number 2. We got 5p plus 7 minus 4p equals 6, 5. Where's an error that could take place up here?
-2.
Yeah, carry that -2. So agree?
Wait. Yeah.
Okay, so again, just make sure you distribute over. Let's see, that's going to give me 16p plus 28. If I subtract 16p from both sides, I wind up with this. Is that true or false?
That's infinite.
28 equals 28? Yes, that's true. Everything fell out. So if everything falls out and gives you a true solution, it means you have infinite solutions.
So you can literally like put down
The sideways 8? What's that?
so can you like put down 0 and that be a correct answer?
No, that has infinite solutions. Infinite means everything works. 0 means nothing works.
No, but can I use 0 as an answer for that question?
You mean like 0 equals 0?
Yeah.
Yes. But then please tell me that 0 equals 0 means infinite solutions. Don't just leave it as 0 equals 0. Cool? All right. So that one got a little goofy. All right, moving on. Whole bunch of parentheses, right?
Yep.
All right. Let's see. Let's see what we combine together. I think I have 19w over here minus 2 equals 19w minus 9. If I were to subtract 19w from both sides, I wind up with realizing that -2 is now equal to -9. That's goofy. This is a false statement, so this means you have no solution. Okay, no solution is a very different answer than infinite solutions, so don't get them confused. called the empty set. Looks like that.
Yeah.
Yes. All right. And then last one, what we got? I'll just write it out. Negative 9 plus y minus 9 equals 81 plus 9y minus 9. Ooh, y minus 9 over here. 72 plus 9y over here. So I could move the 9y over, so I get negative 8y over here equals 81. So y equals 81 over negative 8, which will not reduce. You could also have it like this. Or you could put the negative in the center of the two. What was the answer? What is the best way to communicate with a fish? Drop it a line, huh? Is there anything 1 through 5 you want to take a look at on there? 1 through 5, yeah. 1 through 5, good. 1 through 5.
4.
We'll get to 10. 4? 1 through 5, just number 4, please.
All of them.
That's all right. 12b plus 24 equals 8b plus 40. Let's subtract the 8b, so I get 4b over here. Let's subtract the 24, so I get 16 over here. So b is equal to 4. Is that okay?
Can we do number 5?
5? Sure. We good on 4?
Yes.
Number 5. Let's see. 6. Y plus 8 equals 3. 2y minus 7. 6y plus 48 if you distribute, and 6y minus 21. So I get 48 is equal to negative 21 by subtracting that. That's nonsense. So that's no solution.
Wait, I somehow divided 0y by negative 69 and it came down to no solution.
Where did you what?
Okay, so on the last inner step,
Oh,
I
so,
divided by
so
0.
then you got 69 equals 0? It's still nonsense, right?
Yeah.
Cool. Yeah, it depended upon which way you started on this. If you started just eliminated letters, but like you, if you took care of the numbers, you're going to get still a nonsense solution. Yeah. Okay. 3, 9 plus 5w minus 14w equals 12 minus 6w. Like terms over here would be let's see, I could add 6w, subtract 9, w equals negative 1 if I divide by negative 3. All right, 6 through 10, I know number 10 is on the agenda.
Number 11.
6 through 10, good. Let's do number 10 first. This is a great problem. Couple ways you could approach it. We could take care of the small values, like I could add 6 to both sides or add 7 to both sides. Or I could realize I have 4 terms up there right now. So if I multiply everything by 5 over 1 or just 5, depending upon if it's a fraction or not. This cancels, that gives me 3e minus 30. That cancels, that gives me negative 2, and then e minus 10 minus 35. What are you doing there, sunshine? You got enough?
Not yet.
Not yet. Alright. So continue here, distribute. Let's add 2e. Let's add 30. We find that e is equal to 3.
Wait, can you just play on that phone for a little bit?
Copying it.
Yeah.
So getting rid of the denominators is a big skill. It's a great skill to have. While you're copying that, number 11 says 3 consecutive integers are n plus 1, and n plus 2. 4 times the sum of the least and the greatest integers is 12. Less than 3 times the least integer. What is the least integer? Oh my goodness, there's a whole lot of information.
Oh my goodness.
You prefer to sit sideways, so should we turn your
Yeah.
desk perpendicular so you're actually facing forward? I mean, let me know. I try to make it comfortable for you. You need to spend more time looking over at that board.
We should do homework on this one.
I know. You don't even have your homework, so you can't even do that.
Oh.
Ooh, burn.
Oh.
She said she did it. She just
So
forgot it
burn.
home. All right, let's try and resolve number 11. So we have n plus 1, n plus 2 that they give us. What do you think the least integer up there would be if we're adding 1 each time?
And
Does that make sense?
no.
If I'm adding 1 each time, would n be the smallest integer?
Sure.
Yeah. Okay, so 3 consecutive integers, n plus 1, n plus 2. 4 times the sum of the least and the greatest. So this is the least. This is the greatest. Are we okay with that?
Yeah.
So it says 4 times the sum. What does sum mean?
Addition.
4 times the sum. Did I sum them together?
Wait, where did the extra n come from?
So 4 times the sum of the least and the greatest. The least happens to be n, and the greatest is n plus 2.
But
So we have this one, which is this one, and then this one.
oh, so is that like a separate term? I guess then.
Yeah. Does that make sense how I have it written? So 4 times the sum of the least and the greatest integers is, well, is means equal in math. 12 less than 3 times the least integer. 12 less than 3 times the least integer. What's the least integer? I want 3 times the least and 12 less than that. 12 less than 3 times the least integer. Okay, the least integer is n. We want 3 times that. We want 12 less than that. Okay, solving it. We have 4, 2n plus 2 equals 3n minus 12. Distribute, so I get 8n plus 8 equals 3n minus 12. Subtract 3n. Subtract 8. So it looks like n is equal to how many? Negative 4. So what is the least integer? We said the least integer was n. We know that n is equal to negative 4. Do we need to find all the rest of the integers? Doesn't ask for it. If we wanted to, we just add 1 to that. So negative 4 plus 1 is negative 3. Negative 4 plus 2 is negative 2. Good, though. Good try. No, each time you're plugging this in for n, you plug negative 4 in each time there. We good? Feeling all right? All right, make sure your names are on those and pass them on forward, please. All right, page 23. It says 7B. Worksheet number 7B. Worksheet, perfect, thank you. So let's get it out. That'll be what our notes are. We're going to do some of these problems, make sure we're okay. Okay, I would like for us to get rid of our denominators. So somebody shout out one of the denominators up there. 7. What's another one? 5. What's another one?
15.
15.
3, 2.
We have 5, 15, and 5. Where did the 7 come from?
She
Problem,
saw it.
We're looking at number 1.
problem number 1.
Oh, we're on number 2.
Oh, we're on this.
Well, no, if you turn.
Because he wanted to.
I can see the board.
All right, so if 5 and 15 are my two denominators, what would I have to do to everything to get rid of all my denominators?
75 over 1.
Do what?
75 over 1.
75 over 1? Okay.
Multiply it by 15.
That's pretty big if I have 75 over 1. Yeah, we get the right answer, absolutely. Multiply both sides by 3.
Multiply it by 15.
Multiply by 15.
No.
Just multiply.
If I multiply by 3, I have 3 fifths, 9 fifteenths, and 12 fifteenths. So
15. 15 over 1. 15 over 1.
make the bottom 15. Or what if I do this? Multiply everything by 15 over 1. The reason 15 over 1 works is both 5 and 15 go into it, right?
They go in 3
Watch.
times.
Watch what happens though. 5 goes into 15 how many times?
3 times.
3 times 1 is just 3. So that becomes a nice small 3. Plus 15 reduces here. When you multiply fractions, you reduce top to bottom, right? And that gives you a 1. 1 times 3w is 3w. And then, how many times does 5 go into 15?
3 times.
3. And what is this? Give me 12.
Wait. So you do.
Or just find the equation.
So you have to.
So what I do is my first thing is I look for the least common multiple that 5 and 15 have. Well, 5 goes into 15 and 15 goes into 15. Now someone said let's multiply everything by 75, which is going to get you the same answer as well. It's just your value is going to be a lot bigger. And then once you solve it down at the end, it'll be the exact same answer. So if you don't see the least common multiple at first, go to just multiplying it all together. It'll still work. All right, so from here, I'm going to subtract 3 from both sides. That gives me this.
Wait.
Number 2.
That's why the 2 is circled. And then divide by 3. There's my answer. So clearing the denominator gets rid of the fractions. Now, if you don't multiply by the correct number, you still have a fraction. What part? Understand. Okay, so let me ask you this. What I do to one term, I do to all terms so it stays equal. Would you agree with that?
Yeah.
Okay, so what I'm doing is I'm multiplying every term, being that I have 2 different denominators, one being 5, one being 15. If I multiply everything by 15 over 1, 5 and 15 both go into 15. Right? That's what I'm doing. Here, let's see if we can catch you on this next one. Ready?
Sir.
All right. Coming to you. Ready? I have 2 denominators. One of them is 14, the other one is 7. You agree? So no part of that statement, you're like, I am solid. I'm right with you. Good? Okay. So if I don't want to have my fractions, what is the smallest number that 14 and 7 go into? 14, right? Like 28 would work as well, but 14 also, I like 14 a lot better. It's the smallest. It's the least common multiple of 7 and 14, right? Because 7 times 2 and 14 times 1. Okay, so I'm going to multiply all 3 of my terms. I'm going to multiply this one by 14 over 1. I'm also going to multiply this by 14 over 1. I'm going to multiply this by 14 over 1. And when I multiply fractions together, I can reduce top to bottom, numerator to denominator. So this 14 reduces into here, and that leaves me 1. So this thing becomes 9y. And I'm just going to pause there for a sec. I just want you to make sure you're good. And my conversation's with you and I right now. I know a lot of people are like, dude, go next. I'm waiting till you're solid. Are you feeling okay? So taking a look at that next one, I have 3 over 7 times 14 over 1. Do you or do you not agree or disagree that 7 will go into 14, and if it does, how many times would it happen?
2 times.
Is that all right? So what's 3 times 2?
6.
So now I don't have a fraction there either. Now watch this. Does this reduce into here? What do I have left?
9.
I get it.
You like that? That's okay. Sweet. We gotta make sure everybody gets it. So I have that, and then I'm gonna divide by 9. And a lot of people would get to here and say sweet, but you'd miss a point. What answer am I looking for?
1/3.
1/3.
Wait, is it a negative
How's it negative?
one? Oh wait, wait.
It is possible I made an error with the negative, so don't criticize her if she's pointing something out. I might have missed something. It's been a rough day. It's only second period.
I know.
May I move off this problem?
You may.
Whoa. Tripping over chairs.
He's tripping.
I'm tripping. Can we go? Can we go?
We should go back and do number
Okay. Number 6.
8.
All right.
8.
Can I please try?
8.
Yeah. So what do you want to do?
Let's try 8.
Okay. Does everyone feel okay? I have
Yeah.
3 denominators. One denominator is 4, another one's 2, another one's 8. The smallest number that all 3 of those happen to go into is 8. Does everyone feel comfortable with that?
Yes.
Is anyone kind of like, wait a minute, where's this 8 stuff coming from? I think it should be like 64 or something like that. Which, if it was 64, would work because 8 times 2 times 8, or 4 times 2 times 8 is 64. But the smallest number that would indeed work is multiply each and every term by 8 over 1. Feel all right?
Sure.
4 goes into 8 how many times? So what is this first part?
2
Plus,
4
and then
5.
now there's no more fractions. And life has gotten a little bit better. You, talk to me. 6m, combine it into like terms, and then
Then you got m equals 5 over 6.
5 over 6. And 5 over 6 is already reduced, so that's my answer. What if it's like what?
What if like number 7? They don't go into each other, so how's that work?
Just
gotta
do
do
the
24.
Number 7. Yeah, 24 definitely works. So there's 3 terms. You have 24, 24, and 24. Right? Cool. All right, can I move off here? Feeling all right? So the idea that we're learning today is it's okay to eliminate the denominators. Which I know that you're like, dude, if I could have learned math without having to do fractions, life would have been a lot better. Well, now I'm getting rid of fractions for you. So up there, I have 2x minus 6, and that whole thing is over 4. That's the only denominator I have. So what do you suppose
4.
times by 4 over 1? Is that right?
No. Could just like multiply by 4.
Or multiply by 4? Yeah. Well, this is 4 over 1. Is 4 over 1 the same thing as 4?
Yeah, sir.
So does that make sense that I have up there?
Yeah.
Okay. This goes into here. So I just get 2x minus 6. And then equals negative 28.
Yeah.
So you don't really have to do anything, essentially.
Steven, be this.
No, I multiplied everything by 4. So now I can solve it. Or add 6. So that's what? Negative 22. So x is equal to negative 11.
So, yeah.
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 I said, yeah, but then,
Yeah.
yeah. Yeah.
Anything else? Are we okay?
Can we look at number 7?
What? What about number 7?
The 24 one. Because
Remember-
it's different, so.
So multiply 2/3 by 24. So 3 goes into 24 8 times, so I get 16x there. Following me?
Yes. Wait. Multiply it off by 28.
24. So 24 times 2/3, 3 goes into 24 8 times. 8 times 2 is 16, so I get 16x.
Oh yeah.
And then 8 goes into 16 twice, that gives me 10x. And then 2 times 24 is 48.
You all right? Okay, I got it.
Yeah.
Oh, so you just do the same thing but with a bigger number. How did you?
All right, let's see, what else do I have up here? Number 12, I skipped a little bit.
It's 15.
Number 12, take a look at number 12. What's the smallest number that 3 and 6 both have to go into?
6.
6. So some of you going, but doesn't 12 work? Yes, 12 does indeed work. It's just, it would be carrying through larger numbers. It would be the same answer at the end. So find the smallest number that they go into. So in this case, 6 works. So I'm going to do 6 over 1 here, 6 over 1 here. Now, what's the mistake that's going to take place right here? I actually have the mistake on the board right now.
-1.
Minus 1. There you go. So that's a negative. Remember, that comes down. So I still have a fraction, but let's do this first. Where did the plus 29 over 2 come from?
Because you multiplied it by -1.
So I multiply by a -1. Now I have another fraction. So what do you think I should multiply all 3 terms by to get rid of?
-6.
Okay, you lost me.
Wait, oh wait, oh I see what it is. Okay, I'm still
Using my brain.
behind.
Using your brain or losing it?
Yeah.
Doing both.
Cool. All right, I'm just going to pause there real quick.
I'm losing it by using it.
So I multiplied all 3 terms, so 2 negative x and 29 halves by 2. So that clears the denominator, so 2 times 2 is 4. 2 times negative x is negative 2x. And 29 over 2 times 2, the 2's cancel, so I get 29. What do you think?
-29.
This is I have a question. Why did you multiply the 125%?
At the very, very first step?
Yeah.
Because right now, this would have been just 2 terms. You have 1/3, and this whole thing becomes a term. You could have distributed over, but because this whole thing is 1 term, this is like saying 3x or 10x or something like that. But it's just x happens to be a lot more. Happens to be x minus 29 halves. So it's 2 terms, and that's why I just multiplied the 2 terms. That's a great question. Okay? So we had to multiply by the denominators twice. And then on here, I subtract 29, so that's what? Negative 25 equals negative 2x. So x is equal to positive, and 25 over 2 is your reduced fraction. It happens to be positive.
Didn't you do like 12 and 1/2?
Yeah, I don't think that's the better answer, but yes, you could.
Because
Mixed numbers are really frowned upon in math.
They're bad.
And the reason why is this. So let's say that becomes an answer you have. Still with me? Because let's say you have to carry this answer throughout a problem. Like you're plugging it into multiple iterations of the problem. This will eventually morph into this.
Wait, wouldn't it be 29 over 8?
No, I'm just showing you that what it's going to morph into. Okay? Is 35 over 8 the same thing as 3 and 5/8? No, these are not equal at all. 29 over 8 is the appropriate answer. So how did it morph into it? If you were to have to write this over and over and over again, so you eventually get to something like that, right? Because you're being sloppy. People are sloppy. And then eventually it's like you're going back and look for, and you're like, okay, I got that answer. Well, then all of a sudden I have this answer. Okay, and then you've made an error. That's why it's not accepted. Why did they show it in elementary school? To give you the visualization of where that number would fall. That's why they did it in elementary school. So now we're trying to undo the bidding of elementary school. Make sense? Am I gonna mark you wrong if you make an X? No. But I'm not going to promote mixed numbers. Cool? Alright, last question I want to talk about, that one. How many terms do I have up there?
3,
4. 4, everyone good with 4? I have 1/2 y, that's a term. I have 1/3, that's a term. I have 2, that's a term. And negative 1/6 y is also a term. I have denominators of 2, 3, and 6. What should I multiply all 4 terms by?
6 over 1.
Okay. I'll multiply that by 6 over 1. And this by... Why do you want negative?
Because it's a negative one.
Don't worry about that. We'll take care of the negative later. All right. So 2 goes into 6 3 times, so I get 3 times 1, which is 3y. So that's plus 2. What is this one?
It's 16.
6 times 2 is?
12.
12 over 1 is?
12.
12. Cool. And then I get negative 1y. Okay.
Wait, what? Can you just put negative y?
Yep. All right, add y to both sides, so I get 4y over here. Subtract 2, so I get 10 over here. Y equals 10 over 4. You're happy about it, but I took a point off. Why?
Because you didn't reduce.
Didn't reduce it. 5 over 2 is my answer. Sound all right? Ladies and gentlemen, you have about 10 minutes left. So that worksheet, 23, 24, you have 1, 3, 5, 7, 9, 11, and 13 to work on. You get it done, you got Monday night open. If you don't, get it done. So tomorrow we will continue working with these. On Wednesday we have a quiz. And then Thursday, Friday we start something called absolute values. And absolute value just means the distance away from 0.
What's the
Quiz Wednesday.
Really?
So we're working on this even more tomorrow. So make sure you focus on it. We'll go over those odd problems tomorrow.
I don't like everything that was done in